job is to find the volume of this. Now you have to know a couple things. First of all, you have to know what your cross sections are. There's my cross sections. I put them in there, but you still can't really see them until I drop my y-axis. Now you can see what these cross sections are. What kind of shape are these cross sections? Semicircles. Okay. Now if I put it back and I put my cross sections in there, my cross sections, are they perpendicular to the x-axis or perpendicular to the y-axis? To the y-axis. Now our job is to find the volume. So this is what we're going to do. The concept is you're going to find the area of every single semicircle. Now I only have 5 up there, but there's an infinite number of semicircles in this thing. And so our job is to find the area of every single semicircle and then add them together. That's the volume.
That's a lot.
So how do we do that? Okay, we're going to create a function that will tell us the area of any semicircle. Okay, so let's start with the area of a semicircle. What is the area of a semicircle? The area of a semicircle is pi. Whoop, start writing. Pi r squared, and then we have to then divide it by 2. Okay? Now, all these semicircles are the same, except they're different sizes. And so, what does that matter to my formula? What is changing in my formula? The radius is changing. Okay? All right, so let's look at our radius with it being looking down on it. So you see these lines right here? These are our semicircles, but those lines don't represent the radius. What do they represent?
The diameter.
They represent the diameter. So let's first talk about diameter. How can I create a function for the diameter of each of these semicircles? Okay. Now what is changing here? Is this line changing the diameter? No. Is this line changing the diameter? Yes, that one is changing the diameter. Okay, so let's write the equation of that line. Here we go. You guys remember y equals mx plus b? Okay, y equals mx plus b. Now, I like writing the b first because that one's really simple to see. So what is my y-intercept? I look right here. It says -3. So I'm going to put a -3 for my y-intercept. And what is my slope? Here's the point. Here's the point. My slope would go, whoosh, rise is 3, and then my run is 4. So I'm going to put 3 over 4, x. Now that is a function of x. It's not a function of y. What does that mean? That means you plug in x values and then you get y's. So if I were to plug in x values, I'd plug in this 2 right here. What would that give me? It would give me this point right here. That is 2, -1.5. This function gives me the distance from the x-axis to that point. That's not what I want. That's not where my diameters are. My diameters start right here, and they go out this way. So I need a function of y. So how do we make a function of y? You just have to solve for x. Okay, so let's do that. We're going to add 3 to both sides, so we have 3 plus y equals 3 over 4x. Let's multiply everything by 4. So now we have times 4 right here, so we have a 12 plus 4y equals 3x. Then we divide everything by 3, so then we get 4 plus 4 over 3y equals x. We have it. This is a function of y. I would write it like this. F of y equals 4 plus 4 over 3y. Now, in our context of our problem, what does this give us? If I plug in this -1, this y value, to this, what does it give us? It gives us the length of this line. And that line is what? The diameter. Are you guys still with me? Okay. All right. So some of you guys are actually giving me the number. That's cool. But I'm still like trying to come up with my function for radius. So this is a function for the diameter. So how am I going to make this a function for radius?
Divided by 2.
Divided by 2. So I'm going to divide this side by 2. I'm going to multiply it by 1/2. Actually, everything. And so 4 times 1/2 would be 2. And then 4 over 3 times 1/2 would be 4 over 6, which we can simplify. And then we have, what is diameter times 1/2? Radius. Very nice. I thought you would say 1/2 d. D divided by 2. Okay. Well, you're right, but I want radius. Okay, so we can simplify that a little bit. Now we have a new function of y. I probably shouldn't call it f because we already used f. Let's say a g equals 2 plus 2 over 3y. Whoa. Do you guys see what we just had to do? We did a lot of stuff. And all we did is we found a function for radius. This function tells me how the radius is changing. Let's go all the way back to the area function for each semicircle. Yeah. Oh, you're seeing it coming. You're like, oh, I know, I see it. What's going to happen? Well, we have pi r squared divided by 2. We agreed that that was the area of a semicircle. But now I'm going to plug in something different instead of r. What am I going to plug in? I'm going to plug in my function. So I have 2 plus 2 over 3y squared divided by 2. Okay, now that will give me the area of every semicircle. I just have to plug in the numbers for it. So how do I do that? How do I plug in the numbers and, still have a life? I mean, because there's an infinite number of numbers between 0 and -3. Oh, that's right. Calculus, the study of infinity inside of finiteness. Whoa. This blows my mind. Put your hand down. So this is what we're going to do. Ready? We're going to take the integral of this dude.
Oh, no.
Oh, yay.
We're going to take the integral from -3 to 0. Where did -3 and 0 come from? Yes. So this, what I just did, essentially, I mean, this is our volume. It's the volume of our shape. This is essentially going to take every single number and plug it in and then give us the sum of every one of those. Whoa. It's like the limit. Again. Okay, you guys ready to get busy and down on this? All right, let me reset here because this gets crazy. All right, you see this pi over 2? That's a scalar. I'm going to take him out. So pi over 2, take him out. You could just throw this in a calculator, but we're going to get jiggy with it. Okay, we have 2 plus 2 over 3y to the second power dy. Okay, I'll give you guys an option. You guys want to do u sub, or do you guys want to FOIL this out? U sub? Yeah, me too. Okay, u sub. U is going to equal 2 plus 2 over 3y. Then du is going to equal 2 over 3 dy. And I'm going to put that 2 over 3 to the other side. So then it would be 3 over 2. I have to switch it because you multiply both sides by 3 over 2 to make that 2 over 3 into a 1. Now I have my dy, which I'm going to sub in for that dy. And I have this thing, which I'm going to sub in u for. U will be subbed in. All right, so let's do it. We have pi over 2, -2, oh, no, -3. No, I shouldn't write those because I have to change those. Okay, u raised to the second power, and then my dy is right here, 3 over 2 du. So I'm going to put 3 over 2 in the front, and I put my du right here. And why did I not write the numbers right there? Because these are y values, and I need those y values to be u values. Let's do it now. Plug 0 into this. What do I get?
2.
I get dose. If I plug -3 into this, I get...
1.
2?
don't I get 0?
4? No? Yeah, because it's negative.
Yeah, it's negative. I get 0. Okay, so 0 to 2. You guys still with me? Oh man, I hope I did everything right. Let's do this, because that's a lot of work. All right, we have 3 pi over 4 times u to the third power divided by 3. And I'm going to plug in 0 and 2. Everybody still good?
Yeah.
Okay, let's plug the 2 in first. All right, we're going to write it over here. We have 2 raised to the third power divided by 3 minus 0 raised to the third power divided by 3. And we're multiplying that times 3 pi over 4. This doesn't matter because we get 0. What is 2 raised to the third power? 8. So we have 3 pi over 2 times 8 divided by 3. The 3's cancel out. The 2 simplifies with the 8. The 8 becomes a 4. What do I get? Did I do that wrong?
You turned the 4.
I did do something wrong. That 2 is supposed to be a 4. Okay. You say dang? Dang, he's right. Okay, those go away, and then this becomes a 1, this becomes a 2. My answer is 2 pi. Now if you throw this guy in your calculator, you should get the same thing. Or we can just use my little thing here. Check it out. If I drop this dude and then reveal my solid, show the solid, it gives me 6.28, which is 2 pi. I am awesome. Yay!